coordinates. What type of coordinates have we dealt with up until now?
That's a great question.
Inequalities.
Regular, it starts with an R. Not regular, but
Right.
rectangular coordinate plane. Hopefully, you might have also heard it called the Cartesian plane. Okay? That's what your XY coordinate plane is called. We're going to be going over polar coordinates, which is a new type of coordinate system. So your graphs on these, like not just the graph itself, but like what you're graphing on. It's not little squares anymore. Okay, we're going to be looking at circles.
What?
Which means that what's the important thing that Mrs. Bennett said is not going away, that we really, really, really need to have memorized. So you still have to have it memorized. So if we unmemorized it or never memorized it, you're going to have a tough time on this. So your polar coordinate system is a coordinate system that's going to use two different types of things. So instead of x's and y's, we're going to have r's and thetas.
What?
Huh?
Did you say R and theta?
I did.
R's and thetas.
Why?
Does it mean radians or?
I mean, it stands for radius, because again, we're dealing with circles.
Okay.
I'm not having
It's a movable.
So it is a coordinate system centered around the pole, which is at 0, 0. So instead of calling it the origin, we're going to call it the pole. Okay. And uses distances and angles to describe points. So your polar axis is going to be the ray formed from the pole going to the right. So in other words, it's the positive x-axis.
No.
So polar coordinates consist of a directed distance, which we label as r, and a directed angle, which we label as theta, formed from the polar axis going counterclockwise.
Because clockwise is positive.
Agreed. And that's why it's a directed angle, because we can represent going clockwise by throwing a negative in front, just like with any of our others. Now, have any of us ever watched some of the movies where they have like a submarine or a ship and they're trying to like track someone down, and so like you see the little like screen and It's like blinking as they're like getting closer. Little like radar system, and you notice the circles, right, get smaller as it gets to the center and kind of light up as you get closer. Yeah.
Right.
With the little switch that goes all the way back.
Yes. So that's gonna be pretty similar to what we're looking at.
Oh my
I've seen
god.
that before. I have
You
seen
see
that.
that?
Yeah,
Why?
my teacher showed me in like
It
eighth
looks
grade.
like a
and he's like, you gotta learn this.
Kind of, yeah. So think about where else have we heard the term polar? Polar. The Polar Express, okay,
The North Pole.
which is in reference to the North Pole, okay, and this is
South
so we also have a South Pole.
It makes a circle.
Correct. So it does kind of relate to, you can describe traveling our globe using polar coordinates and polar distances. Because it describes things that are circular better, like our Earth, than traveling in straight distances like our squares do.
That actually
So, we're going to we're gonna look at graphing first. So, on part A, we have the point 2 comma pi over 3. In general, our polar coordinates are going to be written as r comma theta. So your directed distance comes first, and then your angle comes second. So, when we were dealing with our Cartesian plane, each of our little ticks or boxes represented one unit. Most of the time. Here, each of our circles is going to represent one unit. Yes.
So like the point is like determining the vector. You think it's like, is it like a magnitude and the angle, right?
It's a directed distance, so it would be a scalar. And then the angle doesn't really have anything to do with vectors. So our starting spot, like we said, is going to be at our pole, which is in the center. Okay. So if I was looking at 2 comma pi over 3, if each of my circles represents 1, how many circles do we need to go out in order to get to 2? 2. Okay. So I'm going to be at my second circle. Okay. And then pi over 3 is the angle that we need to go. Remember, we are moving counterclockwise. So what quadrant are we going to be in? The first quadrant. So remember, we have pi over 6, pi over 4, and then pi over 3. So this would be point A. Okay. So point B, they give us as 3 comma negative pi over 6. So where would that one be? I'm going to go out how far this time? 3. 1, 2, 3. But now, which direction are we going to go?
The other one.
We're going to go clockwise, yeah? And we would be at pi over 6 from my x, or polar axis. Yes? Now, what about 3 comma 11 pi over 6? Where would that one be? So again, how far am I going out? 1, 2, 3, and then we're going 11 pi over 6, which would be in the what quadrant?
The four.
Specifically where? In the same spot, right?
Yeah.
Now, is there another way that we could represent that same point?
Maybe. Start off bigger circles.
2 pi.
Oh yeah.
Oh yeah.
Okay.
So you could go past 2 pi. So if I added 2 pi to 11 pi over 6, you would make a full rotation and then another rotation. Most of the time with our polar coordinates, we're going to stick between negative 2 pi to 2 pi. However, we said that this first number is a what? It is, which is a what? Which is a what?
A digit line.
A directed distance. Yes. So if it's a directed distance, what happens if I throw a negative in front of it?
It gets.
So I think it might go down the same line, but in like the opposite
So instead of going to the right, I would go to the left, right?
direction. Yeah.
Or correct, sorry. I would go to the left. So then how far away is point B from the left side of my polar axis?
A good distance.
It would be 5 pi over 6.
So yeah, so can't you just like subtract pi and put the first one in there?
Subtract pi from what? The 11 pi over 6?
Yes.
Yes.
Like, I guess add pi depending on where you are.
Correct. Yes. So we can go positive, we can go negative for our angles, we can also go positive or negative for our directed distances as well. Does that make sense? Alright, so now I want we're gonna graph this one together. So we're gonna go out 1, 2, 3, and then we're gonna go negative 3 pi over 4. What quadrant would that be in?
No,
3. Because normally positive 3 pi over 4 would be in my second quadrant, but it's my second quadrant going clockwise, so it's actually my third quadrant. Okay, so now in your groups, I want you to find 3 additional representations of that point. 3. I mean, because it's the same representation, you should have end up at the same spot. So you're just coming up with other points that would end up at the same spot.
Okay. And then
The first has to be 3. Because that's gonna
you do
be
negative 3 dollars.
3 away from the center.
Because it's going this way and then going this way.
Huh? There's a good part.
Negative 3. You're gonna
So you can do a positive number
comma negative 3
that would end up at that spot.
Which would be 3 pi.
because negative 3.
Yep.
And then you go. It gets to the same level,
It's like,
and then you go.
Well,
No,
Yeah, why?
that's way negative.
Why not?
Maybe negative 3 and then like
Why can't negative
pi over
3?
4. Negative 3 and then pi over 4. That's not negative 3. Negative.
Is that 5?
Because if you did negative 3, negative pi over 4.
I don't know. The first one's right for sure.
Because it's going counterclockwise or right.
Alright, here.
3.
Here's okay. No, I'm okay.
Negative 3 pi over 4.
Alright.
Because you're rotating pi over 4 clockwise. Counterclockwise. You're at negative 3. So next over here.
Yeah.
Pi over 4.
Negative.
Not. It's from the here. That's how this was.
Sorry, negative 3.
So now, yeah.
Pi over 4
On
versus
3 represent.
negative 3.
Negative 3 is not on the line though. Negative 3 is this circle.
Maybe.
This is 1. 1 is this circle. 2 is this circle.
But it's not the entire circle. It tells you which direction to go.
Right.
So you're on that circle. So if I use the negative, it tells me to go left.
Right, but it
always
You have to, you can add a
What's the question?
Oh.
Okay. So
That was negative.
if it's negative 3 pi over 4, it would be correct because you what?
Oh.
Because you're going from the left side.
Okay.
So,
It's running in front of
oh, that's in the. So if I went to the left side, basically that's where I started my angle right now.
Oh.
So now if I start my angle from negative 3, right? I know how to already go.
Yes, so back in
You do like,
Alright, can we give me the first one?
you do like,
So using a positive 3, what do we get?
3, 5,
and then you do.
5 pi over 4?
Yeah.
What about if I use a negative directed distance?
Pi over 4.
Pi over 4. And then what about a negative directed distance and a negative angle?
Negative 7 pi.
Agreed. So those would be my 4 representations.
Oh, it's blue guy.
There could technically be more if they allowed us to go outside 2 pi, but because they didn't, those would be the only 4 that we would have. Otherwise, you'd have an infinite number if they didn't give you an angle restriction.
Oh, yeah. Yes, sir.
Questions on that? Yes. No.
Double negative.
Maybe. So. Alright, so next up, just like with our parametric equations, there are times where we want to convert back to rectangular or from rectangular to polar. So we have a set of equations that allows us to do that.
That's very awesome.
Cool. Polar to right.
Rectangular to polar.
Yes.
Oh.
My least favorite.
You're.
The
Alright,
animation of
Do we have those down?
Yes.
Alright, let's look at some examples. So it says convert each point to rectangular coordinates. Okay. So what are our formulas? X equals
R sine it. And y equals R sine it.
so for part A, X is going to equal, what's our R value? 2. What's our theta value? Pi. What is cosine of pi?
No.
Whatever it
-1.
There you go. Which is what? Overall.
-2.
-2. Yay. So then y would equal 2 sine of pi. But what is sine of pi?
0.
So we get,
0.
which means that our overall point is going to be -2, comma, 0.
6. Oh, wait.
Okay?
Wait, what?
Cosine.
Oh. No, never mind.
Question?
No.
So on part B, what's our R this time? Square root of 3 times cosine of pi over 6. Well, what is cosine of pi over 6?
Isn't it like square root of 2?
It
Like
is.
from.
Awesome.
Good job.
So then what do we get overall?
1/2. Right?
Square root of 3 times square root of 3 is a,
Oh, 3.
3.
Oh, wait.
so 3 halves, almost, okay. And then y equals, well, what is sine of pi over 6? The other one, which is 1/2. So we get a square root of 3 over 2. So our point is 3/2, comma, square root of 3 over 2.
Seems that way.
I like this.
Right the other way around.
Yes. Yes. Alright, on our next one, we're going the opposite way. So, what are 2 equations that we're using on this one? Tangent of theta equals y over x, and r squared equals x squared plus y squared.
Yeah.
Okay, so on our first one, tangent of theta is going to equal what? 1 over -1, which is also -1, yes? So where does tangent equal -1?
Negative.
It should be an angle.
Oh.
Negative 135 degrees. No, what is
It needs to be in radians.
So like,
So where does tangent equal 1? Pi over 4, right? So we're looking for the reference angle that has pi over 4 in our second or fourth quadrant.
3 pi over
Or
4. Or
5
5
7 pi.
7 pi over 4.
7 pi over 4. Now, we know which one to use because if I graph in rectangular form -1, 1, what quadrant are we in?
Second.
The second.
The second. So which of our angles do we need to use?
3 pi over 4.
The 3 pi over 4. So for our r squared, we have r squared equals
1 plus 1.
-1 squared plus 1 squared. So we get that r squared equals 2. So r equals
Square root of 2.
plus or minus the square root of 2. But because we start on our polar axis, unless they tell us otherwise, that's going to be our standard. We'll choose the positive one because that's going to be our polar axis with the right side. Unless they say you need to start from the left side of the pole for some reason, then you would pick the negative one. So what would that point be then? So r is okay, theta is, there you go. Because just like our x always comes first here, our r always comes first. Alright, so what about on part B? What do we have this time? Tangent of theta equals, okay, which is undefined. So where is our tangent? Undefined. So tangent is sine over cosine, right?
So where is the cosine 0?
So where cosine is 0.
So at pi over 2.
Agreed. So where is 0, 2 going to be?
Is in the top 2 quadrants.
It's on-
It's in between.
It's on the positive y-axis, agreed? So which one of these is going to correspond with that? Pi over 2. Okay, so then here we're going to have r squared equals 0 plus 4. So what does r end up being? 2. And again, it would technically be plus or minus, but we're going to choose the positive. So we get 2, pi over 2. Questions? No? So now we're going to look at some basic graphs. Later on in the week, we're going to look at some of our other types of graphs that we can get. Some of the graphs are rather interesting. But let's look at our first one. What does r equal? 2. R is your radius of your circle, yeah? So if they don't give us an angle, it's kind of like when we just have x equals 4, right? I have x equals 4, I have all of my y values at that spot, so that's why we end up with a vertical line, agreed? So if I could have any angle, what is it going to give me? All of the angles, but specifically all of the angles with our r of 2, so we end up with a circle with a radius of 2. Okay. But then they ask us to find the corresponding rectangular equation. So what would I do? Which one of our equations has an r in it? Yep, r squared equals x squared plus y squared. Well, if r is 2, what is r squared? 4. So we get 4 equals x squared plus y squared.
Oh, that's all you have to do.
For that one. Because that's the equation of a circle with the radius of 2 and centered at 0, 0. Alright, so now on part B, what am I looking at there? Okay, so specifically pi over 3, so where is pi over 3? And the first quadrant, is it closer to my x-axis or my y-axis?
Y.
The y, okay. So that would be here. But if it can be any radius, what must I also include? The negative as well, right?
Oh, yeah.
Okay. So, how would I convert that one? Which one of our equations has a theta in it?
Oh.
Tangent of theta equals y over x. Well, what is theta? Okay, and what is tangent of pi over 3? So what is sine at pi over 3? Over 2, and then cosine is 1/2. So I have square root of 3 over 2 divided by 1/2. So square root of 3 over 2 times 2. So just the square root of 3. So if I get the square root of 3 equals y over x, how do we usually write our rectangular equations? Y equals stuff. So how would I solve for y here? So what? Oops, that should be 3. What is our intercept there?
0.
0. What is our slope?
3 squared.
Square roots of 3, right? Which makes sense because we're going through 0, 0, and then we have a slope of square root of 3. Now, what about on our last one? What is that graph going to look like? Do we know? It will not look like our secant.
Oh,
wait. So on this one, it's not easy just as to think through, so we might want to start by converting our equation, because that might help us a bit, okay? So do we have an equation that has secant in it? No. Now, would there be another types of equations that we have that has secants in them? Your trig identities, okay. So for our polar equations, which one, or what trig functions do we have for our polar equations? Tangent, sine, and cosine. So which of our trig identities relates secant to one of those things? Which is called the reciprocal identity. So notice that if I divide by secant, right, I would get the reciprocal, which is also what? Cosine. Okay. Well, what is our cosine using our polar equations? So what type of graph is x equals 1? It's just a vertical line at 1. Yeah?
Whoa.
Where would you put x from?
So x equals our cosine. So if I have our cosine, I can just go ahead and plug x in for that. Yes? Okay. So then the only other type that we could possibly see is something that has going the opposite way. So if I have a rectangular equation and I want to write it as a polar equation, so if I have x squared plus y squared equals 16, how could I rewrite that as a polar equation? What is x squared plus y squared?
So 16 is r squared.
Yeah, so
R squared.
Which would also just be r equals 4.
I was overthinking. Easy. I was gonna make it like 4 squared equals 6 squared. I was like, I was gonna like set it up.
Wait, so that'll just be, okay.
She would get our
Or just B.
Alright, what about y equals negative x? What would I want to do?
I'm having good
What are like,
Or
what do you want to divide by
You can
x?
just, yeah, divide by x.
Okay, so I have y divided by x equals -1, okay. But what is y divided by x? Tan, isn't it? Okay, but we don't want to leave our polars like that. Just like we always solve for y here, we always want to solve for our theta. So what does theta equal here?
The inverse tangent of -1.
Which is what?
Pi 4.
Almost.
Pi over.
35 over?
3
5.
numbers.
3.7 pi over 4?
Negative pi over 4? Right, if I take inverse tangent
Oh,
of
you
something.
can just do that.
You okay with that? Alright, and then lastly, what would I do if I had y equals, say, -2?
Oh. Just that.
I can't leave it like that because remember our polars don't have x's and y's, they have
You're
r's
changing
and
it?
thetas,
Oh, okay.
yes.
So -2 equals tan of theta times x. Super helpful.
Okay, so let's think about us going backwards here, right? When I just had r equals secant of theta, I ended up with just an x equals 1,
Oh,
right? I ended up with just x
Oh.
equals a number. So how would I have gone backwards from that? I would have substituted our cosine for x, agreed? So that's what we want to do here.
Our
What would I
sine theta.
substitute for our sine
Oh.
of theta?
And then.
I was looking
wait,
at my
is that-
things and I was like, I'm changing it.
Oh, well,
But what is 1 divided by sine?
cosine.
Cosecant of theta. So that would be our equation.
Yeah. Like, my brain doesn't want to work.
Which part?
Just how that looks.
-2 cosecant of theta? That's the
I mean, it's
equation.
answer.
I agree.
Alright, there is your homework for this section.
And they're all graphic.